My name is Ben Pfeffer, and my advisor for this was Professor Donghui, who I would like to thank, even though I forgot to put him up here. But yeah, I am investigating the impact of local demographic and personal factors on a hypertension diagnosis. So uncontrolled hypertension is defined as having a blood pressure of over 140/90, which can lead to a heart attack, stroke, aneurysm, kidney disease, etc. It affects many organs in the body. Globally, about 30% of adults have hypertension, and in the US, about 50% of them do. And in both of these populations, about 80% of those are uncontrolled hypertension. So there's a need to increase identification of uncontrolled hypertension in those populations. Additionally, there may be disparity in at-risk populations by granularity, so local analysis is important as well. So the problem we're working with is that we're working with a hospital, and the hospital has collected data on patient information, including their demographics and their habits, as well as their blood pressure readings. And because we have all this information, we need to follow the HIPAA restrictions and guidelines, which means I can't show you individual data items today, but I can show you summarizations and the results that we'll get to later. But the hospital has a need to optimize their care based on patient demographics, and they're aimed at uncontrolled hypertension first, at least. So an example of how they optimize their care is by providing additional screening to those at-risk populations. So what we're going to go through today is this process diagram. We're first talking about developing the hypotheses with the administration. Then we have two paths: the internal and external data collection and processing, and merging all the data engineering. Then we get to the data modeling. Then we extract insights from that. And then we can visualize and simplify the results for administrative understanding, because that is the purpose of this. And then we can support and reject our hypotheses from a technical standpoint. So first, the development of the hypotheses. Let me move this.
Just click the X.
A minute.
Show you who this person is.
Okay.
We've even Zoom bombed before. So.
Okay. So we developed hypotheses from mass studies and working with the administration. So we came up with 6 of them, and we decided that these 6 factors are going to lead to a higher risk of having developing uncontrolled hypertension. And the factors are the race being Black or African American, them being lower income, being older, being male, or having a smoking or a drinking habit. So to start to address these hypotheses, we need to perform some data engineering. We utilize six hospital data sets consisting of 4 blood pressure data set readings from March to November of last year, another data set on patient information, including their demographic data, and then the questionnaire results or their personal data. And we calculated the uncontrolled variable as over 140 systolic or over 90 diastolic. If they were over in either one of these, they were calculated as uncontrolled or defined as uncontrolled. And then we cleaned and merged the data sets. And the result was a data set consisting of people with the personal and demographic information, as well as the diagnosis of uncontrolled or not. And this allowed us to address 5 of the 6 hypotheses. But the 6th one had to do with income, so we were not able to address it with the data we were given. But we were given zip code. So what we did was perform external data processing and utilize IRS income tax statistics from 2020, which contained the number of individuals, the returns, the total income, all grouped by zip code. And we took the average income by zip code, and then replaced the zip code in the hospital data set with this new income variable. And this allowed us to address the hypothesis of income affecting hypertension diagnosis. And bonus to this was that it was much easier for the model to understand, since it was one continuous variable as opposed to dozens of dummy columns for all the zip codes that we had. And from here, we just did some data merging, finalization. We ended up at about 50,000 patients with 107 columns, where about 50% of the patients had uncontrolled hypertension, which is higher than the 40% we expected to see. And from here, we got to our modeling. So as mentioned, we had a binary target variable of whether or not they had uncontrolled hypertension. So we performed a classification technique, and the models we considered were logistic regression, random forest, support vector classifier, and k-nearest neighbors. And we used a train validation test split of 70-15-15 and performed hyperparameter optimization. And as you can see in the graph in the top right, the best performing model was the random forest. So we took feature importance from this, and then we selected the top N features from the model, where N, the best N, were defined to be features that, when added, improved predictive accuracy. If they did not improve predictive accuracy or removed predictive accuracy, we did not add them. So we ended up with about 46, or exactly 46 features in our model at the end of this. So then we could extract insights from this enhanced random forest model. And the most impactful features we extracted were obviously age. We all know that has a high impact on hypertension. We also found that the income of the patient or the zip code that they're in, the sex of the patient, and their smoking or alcohol habits impacted a hypertension diagnosis as well. As you can see in the graph on the right, if you guys can read that, age is the most important, followed by income. And then you'll also notice that religion and marital type are in there as well. But since these were in the hypotheses we addressed at the beginning, we're not going to discuss them today, but it is a future step to take. And yeah, the new random forest model with an accuracy of just over 82% with a precision of 0.7827, a recall of almost 0.9, and F1 of about 0.84. And this showed that we had an ability to determine a health factor without any confirmed health indicators. We had some health indicators being smoking and drinking habits, but they were not confirmed, or I'm calling them not confirmed because they were patient surveys they filled out. So it's their own what they say they did, not what they actually did. So yeah, and when we had this, we then needed to bring it to administrative understanding. So this is an attempt to simplify the results so that we can explain importance of variables to administration. So each of these 6 visualizations are the 6 hypotheses we mentioned at the beginning, where the y-axis for all of them is the hypertension prevalence, and x-axis is the factor that affects the hypothesis. So first, looking at the age, we can obviously see as age increases, hypertension prevalence increases as you approach 40. It happens significantly, and then it sort of flattens out after 40, with less people being towards the end. So it goes more haywire there. The next visualization is income. You'll see 2 lines there, the orange line and the blue line. The blue line represents all patients under a certain income level, and the orange line represents all patients over a certain income level. So as the income level increases from 30 all the way to 130 for their zip code, there's less and less prevalence of hypertension in those populations, as the people with more income have less hypertension. Next, looking at this one here, this is male versus non-male sex. We have the hypertension prevalence is higher for male, and we see a similar case for smokers and non-smokers. If you're a smoker or a former smoker, you have a higher hypertension prevalence than non-smokers. And then skipping to the one on the right over there, there are 8 bars there for 8 answers to survey questions answered by the audience, or not the audience, the patients, about their alcohol use. So it's starting from left to right. We have never using alcohol to drinking multiple times per day. And something interesting here is when you never drink alcohol, you have the highest hypertension prevalence. And when you drink multiple times a day, you have the lowest. But if you ignore those extremes, you can see a gradual increase as alcohol use increases. And then the final one here, this lowest bar graph, that concerns race. So our hypothesis addressed Black or African American patients versus everyone else, saying that they had a higher risk for hypertension. But our results show that they have overall generally have lower hypertension prevalence than other races. And you'll notice stars in the corner of 5 of these 6 visualizations. These are for when the difference was statistically significant, given all of the factors. So obviously, when we look at just race here, we see there's the largest difference in a 2-bar graph there. But when we consider every other factor, race was not an impact at all in the hypertension prevalence. So then we could support or reject the hypotheses. As mentioned, if you are Black or African American, you have a higher risk of hypertension. This was not supported by our study, but the other 5 were. And we can also rank them by significance. So the factor that was the most significant, as one would expect, is age, and then followed by income, the alcohol habits, the sex of the patient, their smoking habits, and then the race, which was not important at all. So yeah, the hypotheses supported were that age was the biggest factor, followed by income being an important factor, and then being male, having a smoking history, or having an alcohol drinking history, all lead to an increased risk for uncontrolled hypertension. And the hypothesis not supported was that race, being Black or African American, leads to the highest rate of uncontrolled hypertension. And the hospital can modify their care based on the results of the study, which we'll get to here, the future work. So you can implement the recommendation of additional screening based on these results. But upon implementation, you need to watch out for unmonitored inequivalent care because it can lead to severe biases, and it needs to be constantly monitored and updated, because if you don't do this, then the population that was not at risk will become the populations that is most at risk, because the other one gets reduced so much. So it needs to be constantly updated to make sure you're providing the best care to everybody. Next, we also want to optimize care for other health factors like diabetes, for example. The one that will be continued next in the coming weeks is to determine factors that impact the return to a normal blood pressure. That was the initial goal of this. It's not what we did first, but it is the initial goal. And to do this, more data is on the way to help out. Yeah, thank you.
Any questions?
So regarding the low income, what factors of need with lower or higher income do you think might the diagnosis of hypertension?
It's probably things like you have access to better nutrition. Maybe you can get a personal trainer. It's probably stuff like that. But yeah, that's a good idea.
I have a follow-up question. So does this data set include people who are taking medication to control their hypertension?
If they are taking it and has not yet controlled it, they are still in here.
Okay.
As long as their blood pressure is over 140 or 90 in either of those two fields, it will be considered uncontrolled.
Okay. Is there information about whether or not they're taking drugs to control?
There was not in this data set, unfortunately. Any other questions?
Okay, I guess I had another question about that plot that just was
Uh,
on Ben and Pete. It'll come back up.
oh, right there.
Okay, yeah, the prevalence there.
Yeah.
Is that, I mean, am I interpreting right? That's the percentage of the population that age that has
Correct.
hypertension?
Yes.
That's high. And why
Right.
did it go to 0 at 104? Or
So that's what I was saying. It gets more sporadic near the end
Wow.
because there's no, like, that's probably one person that doesn't have it. Right. So we really care about till it gets to like mid 80s.